Hey gang, this is a quick video in case you're having trouble with the little review assignment for Wednesday, April 1st. So the first 6 problems, the biggest new thing here is when you are raising something to a power that already has a power. Okay, so just a quick reminder that when you have like 2 to the 4th to the 3rd, and a lot of people say that you're raising a power to a power, the shortcut is to multiply those powers. So back when we learned this, we kind of saw why that shortcut works, perfectly. But the bottom line is, at the end of the day, 2 to the 4th to the 3rd, that's going to end up being 2 to the 12th power, which is some giant number. But 2 to the 12th is the answer. If you were talking about, well, I guess right here, x to the 6th to the 8th, you get x to the 48th power, and you can't really do anything with that. Like, we know that 2 to the 16th and 5 to the 30th, those are actual numbers, giant numbers. But we're going to leave them like that, because we have to leave that the way it is, x to the 48th power. But yeah, you just kind of multiply the powers. Okay, and at least for now, that's really all there is to remind you of new from problems 1 through 6. You might have to do multiple steps. There might be a couple problems there where multiplying powers together is not the only thing you have to do. But remember, in this kind of situation, so just like a few more examples, 10 to the 3rd to the 7th, that would be 10 to the 21st power. And let's see, these are a little complicated, so really quick, once you would maybe simplify those together by adding the powers. Remember, this is a different situation than raising a power to a power. Like, it's not like we're doing x to the 3rd to the 4th directly. We're doing x to the 3rd times x to the 4th. So there you would add the powers. That's pretty good with a mouse, if I do say so myself. But once this gets simplified to become x to the 7th, we still have this outside power of 2. So now you have x to the 7th to the 2nd. And that's where you multiply the powers together. Not too shabby. Then for like numbers 7, 8, and 9, there's a plot twist that might have stumped you. So remember that most of the time you get an answer like x equals 6 or x equals -2. You actually get an answer when you get x by itself, right? So obviously that happens most of the time. But sometimes the x variable or the m variable or the t variable, whatever variable you're working with, usually it's x. But if on your way to getting x by itself, sometimes your x variable completely disappears, and you end up with either a false statement or a true statement. And remember, by the way, when you get like x equals 7 or something, that's one solution. But if you end up with the variable totally going away and you end up with a false statement, that means there are 0 solutions actually, or no solutions. And if you end up with a true statement, that means there are infinitely many solutions. Like here, for example, once you distribute the 5 to both of these, and you get 5x plus 15 equals 5x plus 3. And now from here you turn your attention to getting the x only on one side. So let's say we move this 5x away from the right side and we subtract 5x from both sides. Well, obviously that cancels over here, but look what happens. It also cancels there. So what's left is we don't have any x's left at all, and my mouse handwriting is getting worse. But you end up with 15 equals 3, which is either true. It's either true or it's false. Now 15 equals 3, that is false. That's a dirty lie. So the final answer here would be no solution. No solution. Okay. Over here, you get 3x minus 12 equals 2x minus 2. Because remember, first thing you want to do is clear any bubbles that there might be. And if you have a 3x over here and a 2x over here, eventually, like on the next step, you're going to end up with an actual answer, okay? But here, if you have 3x plus 5, and then like over here, you'd want to just combine these because they are like terms that are already on the same side already at the beginning. And so x plus 2x is 3x, okay? And so when you go to move the x's only to one side, let's say you subtracted 3x away from this side, and remember you got to do it to both sides, so we subtract 3x from both sides. Once again, totally disappears, and you're going to end up with 5 equals 5, which is true. 5 does equal 5. And so your final answer here would be infinitely many solutions. Numbers 10 and 11, some story problems, which both of these word problems you can pretty much solve by guessing and checking. Like I'm never gonna knock that method too much. I mean, it's not the bestest, most reliable method in all situations, but if guessing and checking works, then guessing and checking works. But in a situation like this, where you can go a more fancy route, you can write an equation. You can identify a variable. You can like declare a variable for the thing you don't know. Like here, how many hours did Jessica have the bike out for? Like how many hours did she pay for? If we don't know the number of hours, then we can call that h, or we can call it x, whatever you want. And then you can set up an equation. So if there's $10, like a flat fee no matter what, $10 plus $6 an hour, that means we can add 10 plus 6 times h. If it's $6 per hour and there's h hours, we're going to multiply 6 and h. And when we add those two quantities together, that's going to be like your total charge, your total amount paid, which in this case is 28. So here's your equation, and now you can just solve this for h, get h by itself. And this is a pretty simple equation to solve compared to others. Here you could just start getting h by itself immediately by first getting this 10 out of here, away from the h, because we want h to be the only thing on the left side. So let's get rid of the 10 by subtracting it. Remember, we got to do that to both sides, so that would become 6h on over here, and over here that makes 18. And now we got to get rid of the 6 by doing the opposite. 6 times h, the opposite is dividing. And we got to do that to both sides to keep the equation balanced. And we would get h equals 3. This next sort of unique example talks about consecutive numbers or consecutive odd numbers. numbers or consecutive even numbers, or like I already said, just consecutive numbers, period. Consecutive means in a row without skipping anything. So consecutive numbers would be like 7, 8, 9 or 23, 24, 25. Consecutive odd numbers, for example, would be like 17, 19, 21, because they're consecutive odds in a row. So another example would be like 51, 53, 55. And so you're looking for a consecutive odd numbers that add up to 99. So how could you do that? You could like declare a variable, for the smallest number. And I guess I'm going to get a little thorough here. I wish I wasn't just using a mouse. But, there's 3 mystery numbers, x, y, and z. But having 3 different letters in your equation, you can't really do anything with that, okay? But if you can use the fact that they are consecutive odd numbers to your advantage, we can do this. If we're calling the smallest number x, then wouldn't the next biggest number be x plus 2? Like whatever this number is, isn't the next number that number plus 2? And then wouldn't that make, instead of calling the biggest number z, couldn't we call it the smallest number plus 4? And this is a new and improved equation that you can actually solve, because now x plus x plus x is 3x, and then 2 plus 4 is 6, and you can kind of go from there. If it was just consecutive numbers, period, like not consecutive odds or consecutive evens, if it was just consecutive numbers, then you could call the middle number just x plus 1, and you could call the biggest number just x plus 2. Hope that helps. If there's still lingering questions, please feel free to email me or something, okay?